Okay, method of joints. So you'll need this for your external information, just to prove why you can hold so much weight. Okay, so I am recording this for everyone else's benefit. It's on my phone. I'll have to download it and flick it through, so it'll be on Teams as a recording.
What are you doing?
Method of joints. So it's how we prove the external forces that we're using. So the ones that we should have already determined how much weight we're using. Okay, with the full panel points. Okay, and I'll do some information on that, how we go about determining whether or not the material is able to hold what we can have. So, first things first, so method of joints.
No. James.
I don't know whose that is. Please, it's just one of those things you need to make sure you have a name on it.
Because I think it's this one.
Wait, you sure? Wait, let me
That one has Legion's name on it.
Logans? Which one's Logans?
This is a bunch of writing on it.
It's probably like
Max. Which one's Max's?
I don't know. And there was Jaden's. And that was
mine.
So mine's over there. What about yours as well?
I didn't finish one.
No.
Or that's what I remember at least.
Then a process of elimination. This should be process.
Probably. Most fun.
Okay, so if you've, yeah,
I've double checked that really.
yeah, is that yours?
No, mine's over there.
Whose is that then?
I'm trying to figure if that this is Max's.
Uh,
Is he wanting me to do testing for his as well?
yeah, I think. Logan's already done testing.
Okay. Phantom's Logan's though.
Good question.
Because Alicia's his name.
Yeah.
You can tell which one's Jason's. Broken got his done.
To
And there's this one and written on one.
And the written on one's Logan's, because Logan comes all his
Measurements.
Measurements
So
on
then
it.
this one should be Max.
yeah, very good. Okay, so method of joints. So first of all, we'll draw up our diagram. Are you gonna? Yeah. Okay. Next thing, we're going to put in our full panel points, okay, which will go on to the joints that aren't the end ones, okay. So has someone, I think I ended up with 3.6 kilonewtons on these ones. So I'm just going to work with that. You guys substitute your numbers. Don't forget.
6 kilonewtons on the
That was for a full panel point.
on the actual roof or the.
Yeah, on the truss. So everything, remember with it, so full panel points was our dead load
Can I just
times 1.5 divided by total number of trusses. Okay? Okay? And then divided by how many full panel points. So hopefully we did that a while back, 2 weeks back. So you should have that information.
How is yours so low?
3.6,
Yeah.
because I chose quite a light material.
Oh no.
Mine's similar as well.
But that's kilonewtons, still kilonewtons.
Mine's 19.6 newtons.
Newtons.
Was that for your, remember that was the testing we did on your
Oh shit.
testing one?
I don't know if I've got.
So what was your dead load? So let's quickly grab that. dead load.
With the safety factor.
Yeah, with factor of safety,
1,035.
35.
7.741 kilonewtons.
1,037 4 kilonewtons. Was that on all of this, or was that in total?
In total, it was the load on each truss is 51.787 kilograms.
So 51.78, let's 79, okay, kilonewtons. And then you divide it by, so how many trusses, how many points do you have? So for Brody,
7.
sorry,
7.
it's on the other side, it's on this side.
Yeah.
Sorry, 7.
Yeah.
So 1, 2, 3, 4, 5, 6, 7. Was that yours?
Just on the top.
Yeah, just on top.
Oh.
5.
Yeah.
So that's 1, 2, 3, 4, 5. Correct, Brody? So you're taking away this one. So you got 1, 2, 3, 4, 5. Okay. Now you'd actually divide it by 4 because these ones are half. Okay. So in mine, not 3.6, it would be 1.8. Okay. So you divide that by 4, and that you'll get your full panel point.
So that'll give me in aluminiums on each.
Yes. And then, yeah, so you go on the ones that are full is the full amount, and then at the very end, they're halved.
Oh, so it's 12.9 kilonewtons.
12.9. Okay.
Isn't that a lot?
Well, you've chosen a much heavier I believe you've chosen a much heavier steel.
Mine's 2.6 on a full panel point.
Yeah, and you've chosen aluminium.
Isn't yours steel?
Yeah, it is, but I also went for a very small channel, like 70 by 40, so really small. Okay. So, now that hopefully you've got that, then what do we need to do? Then what we need to do next is we need to determine the external reactions. Okay. So we have the only ones that are relevant are our upwards ones. So we go A, well, let's just label off B, C, D. So E, Y, A, Y. Okay. And then E, F, G, H, I, J. So I label off my drawing external reactions. Now, this is a reminder, so it's the same as what we've done last term. Okay, so we go and for the beginning of this term, so we start with moments. So moment around A equals 0, sum of moment around A. Okay, so we can take out that becomes 0, so we got negative 3.6 by the distance, which in my case was 4.167 because I divided it up equally, minus 3.6 by 8.33 minus 3.6 by 12.5 minus 3.6 by, just get my calculator, 12.5 by plus.
4.167, where is that from?
So that's that distance there, because I did this equally. So all of these were exact. So from here to here, that was a third, that was a third, that was a third.
But
In my calculations.
isn't your first 3.6 not on that dot?
It's on this one,
Yeah.
but it's pushing straight down.
Yeah.
It's not on an angle. It's not the angle. Stop. It's not the angle. It's here. It's as if you take it down to the.
Yeah, when I just asked when you get your 4.167, you said it's still there.
No, here. This one here, J. So whatever that distance there is. Okay? So if I went equal, another one for this. So just distances, 4.167, 4.167, 4.167, 4.167, 4.167, 4.167. Okay? So if you divide 25 by
And is
6.
Is there a moment if they're both pins?
This one's a pin, this one's a roller. But yes, there
Aren't
is.
roots just both pins?
No, you'd actually have one as a roller. And the reason is because, remember, the ground does move ever so slightly. Okay, I'll keep going. So 3.6 plus times 16.667 minus 0.5 plus 8.33, 3.6 by 20.83 plus EY by 25, all equals 0. So 15, 29.99.
So what would we do if we decided to have them as both pins?
Doesn't matter, because you can still have a moment.
But it's not able to.
Yes, but you can still have a moment. You can still calculate it as if it's a moment.
I thought a moment was always around a roller.
No, it's around a pin. It's around any joint. It's around any joint. Because it is 0. Because it is 0, you're pretending, yeah.
Oh yeah, because it's an equal number.
Oh, and I forgot the last one, sorry. Minus 1.8 by 25 plus EY 25. I was like, I'm missing one. Negative 15 minus 29.99 minus 45 minus 60 minus 74.99 minus 45. So EY 25 equals 269.98, which will equal 269.98 over 25. EY. You guys have done. You should have done this before. You have done this before. So, yeah. 7, 9, 9. Rounded down to 10.8 kilonewtons. Okay. Then, of course, solve for sum of forces in the y direction equals 0, positive going up. We have AY plus 10.8, which is EY, minus 1.8, minus 3.6, minus 3.6, minus 3.6. 1, 2, 3. 1, 2, 3, 4, 5. 3.6. 1, 2, 3, 4, minus 3.6, minus 1.8 equals 0. And 1.8, yep, so negative 1.8 minus 3.6, minus 3.6, minus 3.6, minus 3.6, minus 3.6, minus 1.8, negative 21, AY plus 10.8 minus 21.6 equals 0. 21.6 minus 10.8, 10.8 minus 21.6 is negative 10.8. Negative 10.8 equals 0. AY, sorry?
It's 10.8 going in the upward direction.
Correct. And therefore, AY
Oh no, that'll be going down.
10.8 upwards.
If it's a negative and you've already assumed that it's going upwards. then
No, no, no.
it's going down.
Remember, it's on the opposite side of our equation first. So we've still got the 0 and it has to come across. Okay. Yeah, it's a hard one. Did I get everything? I think I've just captured everything in the
What about
EY
EY?
is 10.8. So now that we have that information, sorry?
Isn't that the moment?
But we're using the moment around A to find this unknown, because remember we multiply the distance by the force by the distance to get the moment. Okay, so that way we can eliminate A, because A times 0 is 0. Okay, does that make sense? We've done this before. You go back and do that. Okay. This is my work. Please make sure you're using your work. Okay. So now that I've got AY 10.8 and EY equals 10.8 kilonewtons. Okay, I can erase that. Well, for me, I'm erasing that. You guys can start a new page. Okay, I'm actually going to quickly erase this. Okay, so I've got 3.6 and 1.8. Right. So now we need to organise our joints. Okay, so what are we putting on each joint and how are we calculating it? So, easy enough to start with just your dots, where A, you go up, or however you're going up or down. Okay, we have one in the middle, one there. Okay, so I haven't put any stringers in yet. Okay, first things first, we put in our external forces. Okay, so let's put in all of our external forces, including our reactions. 1.8, 3.6, 3.6, 3.6, 3.6, 3.6, 1.8. Then here, 10.8, 10.8. That's mine, just don't forget yours, okay? Secondly, we'll need to make sure, you should have calculated it from before, but your angles, okay? So this angle here is 21.6, I believe was correct. Was it 21.6 or 21.8? Because everyone should be the same for that one.
Which one?
The angle ABJ.
21.8.
21.8.
Yes, it is.
Thank you. Everyone should be the same for that. Okay, and therefore you go from there. Hopefully you've calculated your angles that you'll use elsewhere. Okay, now I had my book somewhere with my working out. I was going to do this last week, so I think I've left my book floating around somewhere. Very good. So remember method of joints. Label your joints. So A, B, C, D, E, F, G, H, I, J. Now we're gonna now do our internal forces acting in, so acting on the beam. So
Is this still method of joint?
this is still method. This is the next step in the method of joints. Okay. So what we're going to find now, so we're going to assume everything's in tension. Okay, which is pulling away from the joint. Okay, so we draw up our arrows. So all of them essentially for this first bit, all of them we can assume as in tension and therefore pulling away from the joint. So there's a lot of joints, a lot of arrows to draw. Okay, can't really be helped. And final one here. Okay. So we're just going to assume all of the joints for now are in tension. I'll write that up here as a rule. Assume all joints are in tension. Okay, so now we're going to break away. We're going to break out some of these joints and just work on them. And the reason is, all we really need to find out is that with the amount that we've worked out, total dead load with factor of safety, will the beam cross section, okay, carry that weight? Okay, so we need to essentially get to this one here, IJ, because everything else, once we get to IJ, we can actually determine whether or not that is going to be a good fit. Okay, once we've determined IJ, you can continue on and work out, but you only need to work out AJ, AB, BJ, BI, HI, BH, BC. So you just need to work out the ones that I've circled. Okay? They're a bit harder to see, but I'll okay, it's really hard on a whiteboard, much easier on paper to make it clear. Brody, focus please. Right. So we're just going to focus on joint A first. Okay, so joint A. So let's just do a quick drawing. Okay, so A, we have two joints, 21.8 degrees. We have our force acting down 1.8. We have our force acting up at 10.8. Okay, and we have AJ and AB. So, first of all, we're going to work in the vertical direction, Y direction. So sum of forces in the Y direction equals 0. That eliminates AB. Okay, and we're going to remember our SOHCAHTOA. So opposite, adjacent, hypotenuse. Okay, so we're just going to work with AJ. So we need to find AJ. So we have, let's positive direction, everything's going in the positive, is up. Okay, so we have 10.8 is positive minus 1.8, which is negative, plus AJ sine 21.8. Okay, because sine is the vertical component. equals 0. So 10.8 minus 1.8 is 9 plus AJ sine 21.8. 0, AJ sine 21.8 equals negative 9. We minus 9 both sides. We then divide by sine 21.8, so negative 9 over sine 21.8. So negative 9 divided by sine 21.8 will be negative 24.2324 kilonewtons. Okay? .24 kilonewtons, and that will be compression. Okay, because we've already assumed all joints are in tension. Because it's the opposite, it's a negative, it becomes compression. Okay, AJ. Now we can solve for AB. Okay, and we go that way, positive. So we have sum of forces in the x direction equals 0. The 10.8 and 1.8 are negated because they're 90 degrees. Okay, so we have AB plus AJ cosine opposite of sine 21.8 equals 0. Okay, we know that AJ is a negative number, so AB minus 24.24 cos 21.8 equals 0. AB is going to equal, then we take 24.24 cosine 21.8 onto the opposite side. We add it on both sides of the equation. 24.24 cosine 21.8. So AB will be 22.51 kilonewtons. And that will be in tension. Does anyone have any questions so far? So that is joint A. Right? Now we need to go choose a joint that has only 2 unknowns, not 3. Because if you have a look at B, we've got 1, 2, 3, 4 complete unknowns. We've only got at point J, we know AJ, we've got 1, 2 unknowns. Now this is where people get confused last time. Please remember this rule. When you're doing it, you choose the X and Y axis that is most prominent. In our case, it will be on the AJI line, will be the X axis. Okay? And then I, with Y axis, will not be opposite to BJ. Okay? But we can therefore solve using cosine and sine for the BJ.
This is really random, but what's the method of joints going to get us for answering things that are assigned?
So what we need to do is we need to find this information here. What is this tension here, or compression, at IJ at the very least. So if this is bigger than AJ, then we can go, which it should be because it's 3.6 is our most worked upon. Then we can go, what is the force acting across the cross section? So force times area, which is stress, and then we take that information across to our table that says ultimate tensile stress will be in MPa, and we go, the steel that we've chosen has 300 MPa. This cross-sectional here will be 42, 43 MPa. 43 is less than 300. It'll hold. That's why we're doing it. Does it make sense? That's why we don't need to find every single...
So we're literally just doing
You can, for this assignment, just do 2. As long as you've got it and you've got the maths somewhat correct, you only need these 2 joints. Okay, so joint J. So again, let's draw it. Okay, so we have these are all the forces that are acting upon it. So we have 3.6 acting at the top. That's our X, and this is our Y. Now, when we have this angle here at 21.8, I also had that would be equal here, so that's also 21.8. So therefore this angle in here, so it was 180 minus 21.8 minus 21.8 was 136.4. So I'll put this in a different colour. So 21.8, 21.8, 136.4. And then we go 180 minus 136.4 to get us this one here, which is 43.6. This is important information, okay? Like I said, what I'm drawing is not it's not scale. If it was scale, it'd be much different, okay? And we know that this angle here would be 21.8, okay? Because as you're rotating the vertical, this information here, 21.8, that would, you're just moving it. So that's 21.8 using the Z rule. So that's our, do you know that?
Yeah.
Mm-hmm. So that's our angles. We need to know the angles. Okay?
Yeah, we've already got them, don't we?
Hopefully. Okay. So, once we've done that, we are going to solve for y first, which will negate AJ, which we've already got, calculated in IJ. We are only looking for BJ. Okay? So, that's what we're looking for. So we're going to use the y direction first. So sum of forces in the y direction equals 0. And in this case, we'll be down because we're following BJ. Okay? BJ being tension, pulls away from the joints. Okay, so let me just quickly, if I were
Can you
to...
just find IJ first, if that's the only one that you need to look for?
Sorry, no, because this is on an angle to y. You actually need to have BJ solved first before you can solve for, because that will act on the x-plane as well. Or all 3.6 IJ, BJ will act on the x-plane. So solve for the y first, because it negates that line. Okay? It zeroes those out. So I'm just quickly drawing up a diagram, so if that's 43.6, Z rule, that's 43.6. There's my right angle. Okay, so this is looking for opposite of 43.6. Okay, that's proving, here's my adjacent, here's my hypotenuse. Okay, because that's that little diagram, because this one's not to scale, that one's a bit more to scale. Just a little bit. Okay? So, I've
Have
literally...
you changed the y-axis to be in line with BJ?
No.
That's what's on your...
This is wrong, so I had to do a diagram that it wasn't.
So what's that number?
This is Y here,
No, what's the angle?
43.6.
How have you gotten that?
43.6,
Yeah.
Z rule. So this angle here is 43.6, right? And then that's the hypotenuse. And if I do a 90-degree line from the y-axis to that joint, to that line, to this force,
What if it was a 90-degree angle to that line, then it wouldn't be the Z rule?
but it would be.
But it wouldn't be on the same angle as the x-axis.
Yes, it would be. But that where I've put it, here it is. That's where it is.
Wait, where's the 43.6 degrees going? On the truss?
So, here's my Y. Okay? I have my truss going that way, and I have at this point it goes like that. Okay? So I drop a line to get 90 degrees. Okay? That is also 90 degrees here. Okay? That is from here to here. The dotted line to that line. This angle's 43.6. This angle will be 43.6 because this is the Z rule that's happening. Does that make sense now? Now that I've color coded it? Because if I don't find that out, I can't find the vertical, the Y component. It's harder to solve for the Y component of BJ. Remember, we're using trigonometry. Okay. I'll get through it. Please let me get through it. I know we've only got 20 more minutes. Okay? And then we've got 3.6, 21.8. Okay? And again, if I dropped a vertical, so that's opposite, adjacent, hypotenuse of that one. So, sum of forces going down. So we have 3.6 sine 21.8 plus, so it's going down, BJ sine 43.6 equals 0. Okay? It's rearranged, so we have BJ equals negative 3.6 sine 21.8 all over sine 43.6. Sine 21.8 divided by sine 43.6. So BJ will equal negative 1.94 kilonewtons, which will be compression. So that'll be pushing up against the joint. Now we can solve for Fx now that we have BJ. Okay? So we're using A, the adjacent, so cosine 3.6 and cosine BJ. So sum of forces in the x direction equals 0. So which is going that way. So plus So we have, let's start with IJ, okay, plus because that's AJ going that way, so minus AJ. The 3.6 is going the opposite direction, so minus 3.6 cosine 21.8. BJ is going in the same direction, plus BJ cos 43.6 equals 0. So let's put in our numbers. IJ is the same, that's what we're solving. AJ is a negative, okay, so it goes positive 24.24 minus 3.6 cosine 21.8 minus 1.94 cos 43.6 equals 0. It's 0. So 24.24 minus 3.6 cosine 21.8 minus 1.94 cosine 43.6. So IJ plus 19.49 equals 0. IJ will equal 19.49, negative 19.49, which is compression. So is net IJ less than AJ? Gentlemen, IJ less than AJ? No?
Yeah.
No?
No, it's not.
24.24 compression versus 19.49 compression. Therefore, we can solve using 24.24. Okay, so cross-sectional area. So this is where we're all leading to, okay? So we're going to use AJ as our point of reference because that's the most amount of force, okay? So, cross-section area. I might do this in a completely different colour. So using AJ, solve tensile strength. Okay, so we have cross-section area times force, okay, will get us our stress, sorry. Okay, so I can, if I get my laptop up, get my mouse out. Oh, it's already there. Just for my. So I just literally went, just quickly found this. H was 70, 40, or 75, I think I initially did it as. 6 and 6, area 858 square millimeters. Okay, so for me, okay, I had 858 multiplied by 24.24 kilonewtons. Let's get it down to newtons per millimeter squared. Okay, so 858 by 24240 newtons, so millimetres squared by newtons. 858 by 24240, 20797,920, and that's in pascals. Okay, and then we want megapascals, which is 1,000,000 of them. So that's where 20.79 megapascals. Okay. So I can go from here, and I can go with 20 point, and I find that I have that information. Hopefully, you have that information about the tensile strength from your research of your steel, which should be usually around 300 to about 700. Okay, 300 to 450. So I would say that mine is going to hold. Okay. Okay. Sorry, what was that, Halil? I'll wrap this up. If you have any questions, please come and see me. Okay? We've only got till Friday. Okay? Use the Teams, ask the questions. Okay? I'll just stop recording for these guys at home.